Hi everyone, I'm Cristian Manuel Soto Paz. This is my project for the International Material Research Congress 2025, and the topic of my project is solubility effects on the mechanical properties of polymer solutions and experimental and molecular simulation study. I am studying the University of Guanajuato, so this is my project. Well, in this project, we have investigated the influence of the solvent on the mechanical behavior of polyethylene oxide solutions, varying the concentration through rheological experiment and molecular dynamic simulations. The solvents used were water, glycerol, and binary solutions of both solvents. Water dissolves pale will because of its polarity and the small size of water molecules. In contrast, glycerol gly- in contrast, glycerol struggles to dissolve PO because of its larger size, especially when the PO has a high molecular weight. Well, the behavior of polymer in solution varies depending on the solvent selected. The way the polymer falls is directly affected. In a good solvent, the polymer will exhibit stronger intermolecular interaction rather than intramolecular ones, resulting in minimal folding. Conversely, in a poor solvent, the polymer tends to favor intramolecular interactions over intermolecular ones, leading to increased folding and even potential precipitation of the polymer from the solution. The polymer's behavior can be analyzed using the Gibbs free energy equation. If the Gibbs free energy is less than zero, the mixture is favorable. If greater, the mixture is unfavorable. A precipitation may occur. The Gibbs free energy equation incorporates enthalpy and entropy terms. Using the Fleury-Huggins theory, we can express the Gibbs free energy of a polymer solvent mixture in terms of the volume fraction of the polymer and solvent, as well as the Fleury-Huggins parameter. This parameter depends on the coordinate number, and this is the number of neighboring molecules interacting with a given molecule, the interaction energy chains. Uh, this is the difference between polymer-solvent interactions and solvent-solvent polymer-polymer interactions, the Boltzmann constant, and the temperature. Well, later we have the mechanical properties of solutions. So the choice of solvent affects the mixture's response to mechanical deformations. It's a rheological behavior. For a Newton fluid subject to the formation between two plates at a specific gap, viscosity can be determined using the standard equations. However, the other rheological behavior exists, such as shear thinning, and this is when the fluids that degrades in viscosity as the formation rate increases. In this case, this is the shear thinning and the shear thickening. The fluids that increase in viscosity with the higher deformation rate. This is the shear thickening. These viscosity values are measured using a rheometer via a flow sweep test, where the sample is subjected to an increased deformation rate. Another case aspect is the viscoelastic behavior, characterized by storage models. In this part, this is the storage models, and this indicates elastic behavior, representing energy stored during the formation. This means the fluid have a behavior of elastic, solid, solid like elastic behavior. And we have the loss models. The loss models indicates a viscous behavior and representing energy saved during the formation. Uh, Other important term of this is the reelection models. and this describes the stress relaxation over time after applying a constant strain or stress. Well, these measurements are performed in a barometer using an oscillation frequency test where the solution is subjected to oscillatory deformations. And if G or the storage modules is more than the loss modules, the fluid behaves as an elastic solid at an angular frequency. However, if the curve cross and the loss module is more than the storage modules, the fluid transition to viscous liquid behavior. So, in this project, we have a different concentration of the solvents. The first one is with the water to 4.5 milliliters, and the glycerol is 5.5 milliliters. And the concentration of PO is the same in all of solutions. We have a difference in the solvents. We increasing the water volume in the different solvents, and we have obtained different mechanical, well, rheological properties. So the methodology is very simple. We weigh the glycerol because the glycerol is a viscous solvent. So probably if we try with the volume, we have problems to the measure of the volume of the glycerol. So I think it's better with the glycerol, and later we mix the glycerol with water. Later we weigh the solution, the total solution, and later we weigh the PO. Finally, we mix the solution with PO, and we mix that final solution with head for 24 hours. Finally, finally the viscosity and viscoelastic from flow sweep and oscillation frequency experiment is measured using a barometer. In this graph, uh, we have see a viscosity decreasing as water content increases in the mixture, highlighting the dominant contribution of glycerol viscosity. This part, the purple line, is for the first sample, and the first sample is 4.5 milliliters of water, and the rest is glycerol. So we can see the viscous is more to the other samples. In the other case, in the last case, we have the just water with polymer, so the viscous is less to the other samples. In this graph, we have the behavior of the samples in the loss models. Well, the graph of loss model exhibits a decreasing viscosity behavior as a water content increases in the mixture, but it seems to similar slopes. So we can see the difference of all of samples in the behavior in the viscosity behavior, but that's have the same slope, well, similar slopes. And in the other case, in the graph of storage model, this exhibits increasing elasticity behavior as water content increases in the mixture. Mixtures with a low water content are prone to measurement error. In this part, the sample 1, 2, and 3 have a, a measurement error because the behavior of the part of the storage model, or the behavior elastic like a solid uh, is not the better for mediation. So we have this little error in the mediation, in the measuring. Sorry. Well, perspective to perform molecular dynamic simulation that mimic experimental rheologic properties. Simulation result helps to explain how the polymers shape and distribution related to flow and viscosity properties measured in experiments. Uh, the molecular simulation have a different advantage of the uh, to try to understand the different behavior of the solution, the polymeric solution. So this the molecular dynamics use the Newton laws for the implementation and integration of the different equation for the simulation. So we can obtain the different experimental results like the viscosity or the viscoelasticity behaviors. Well, second one, we want to analyze the behavior of polymer molecules in the mixture using molecular dynamic simulation, and we want to study similar system with a polymer of different porosity in other solvents. And well, this is the project, so it's all. Thank you, everyone.